Hi, my name is Saket Kenjale, and in today's video we're going to be going over section 1.1 Review Functions Part 2. So we're going to jump straight into an example problem which reads, for each of the following functions, find the domain and the range. So I want you to pause the video and see if you could solve these three problems. Okay, let's start with Part A. To find the domain for Part A, I'd say that it's best if we draw a graph for this function. We know that it's a parabola because it's in vertex form, and it has a translation of 4 units to the right and 5 units up. And its vertex is going to be over here. And we know that it's going to go up. So just by that, we can see that the domain goes from negative infinity all the way to positive infinity, just because of the fact that it goes all the way to the left and all the way to the right. To solve for the range, we have to look at the lowest point on the graph, which is, in this case, is a vertex, and that is negative 5. Then it goes all the way up to infinity. So the range of this function is 5 to infinity. Now let's look at part B. Now this question is a little bit more involved, so I'm going to walk you through it slowly. So this is the function that we're looking at, and the original function for this, which is a square root function, the original square root function, looks like this. It starts at 0, 0, and then it goes up like that towards the right side. So it starts from the point 0, 0, and it goes all the way to infinity. So for this function, the domain would go from 0 to infinity. But you can see in our question that we have some translations and some stretches. So what we want to happen is that we want this term over here to be equal to 0 so that we could solve for the beginning of the graph. So if we set 3x plus 2 equal to 0, we will get that x is equal to negative 2 over 3. And so the domain will go from negative 2 over 3 all the way to infinity. And the range is much easier. We could see that there's been a translation 1 unit down over here. And so it goes from negative 1 all the way to positive infinity. And so for our last question, to find the domain, we have to notice that if we were to plug in the value 2 into this equation, we will get an undefined value. So if we were to plug in f of 2, it would equal 3 over 0, and that's undefined. So that won't work for this function. So the domain is going to go from negative infinity all the way to 2, and then there's going to be a union, and then it'll go from 2 all the way to infinity. For the range, it gets quite a bit more complicated, but I'm going to walk you through it. So if we look at our function 3 over x minus 2, if you plug in points, you would notice that the closer x is to 2, the more greater the magnitude of the f of x value or the y value will be. So the greater x is, the greater y is. But if you were to plug in a really distant point from 2, then you would have 3 over a really big number. and that's basically getting closer to 0. It's not exactly 0, but it's getting closer to 0. And so what's happening, if you were to graph this on Desmos or something like that, then you would see that the graph looks something like this. So this is 2, and the graph goes like this. I'll draw that better. And this line over here is getting like closer to 0, but it's never actually gonna get to the y-axis. I mean to the x-axis, sorry. And so the range is gonna go from negative infinity, because we see it goes all the way down here, and then it goes to 0, but it doesn't include 0. Here, let me put this in a different spot. So it goes from negative infinity to 0, and then it goes from 0 to infinity. But this graph doesn't include 0, which is why this is our answer. Now we're going to talk about different ways we could represent functions. So I'm assuming you guys know all of these representations. So we have a table like this over here, which has an x column, an x row and a y row, and together they make coordinate pairs like that. There's a graph, which I showed you earlier, which is an xy plane, which has a function on it. And then we have formulas, which is the questions that we've been solving. So now we're going to look at the vertical line test. So what makes a function a function? So if we read this, it says, when drawing a vertical line through a function, it should intersect the graph of f no more than 1 point. It should only intersect the graph one time. So if we were to draw something like this, let's say, if we were to draw one vertical line, then we see that it intersects multiple points. So because of that, this is not a function. If we were to draw something like this, it goes all the way through. This is an example of a function, because if we were to draw a vertical line down this, we see that it only intersects 1 point every single time we draw a vertical line anywhere. So that's why this is a function and this is not a function. And another important thing to note is that a function can be increasing on some intervals and decreasing over different intervals. So if we were to draw this sine graph again, we could see that over this interval from here to here, it is increasing, and then from here to here, it is decreasing, and then it increases from this to this, decreases from this to this, and so on and so forth. So that is another important thing to know. Next up, we're going to be talking about combining functions with mathematical operators. So given the two functions f and g, we can define 4 new functions using the 4 mathematical operators. So we could have f of x plus g of x, f of x minus g of x, f of x times g of x, and f of x divided by g of x, where g of x is not equal to 0 because otherwise we'll have an undefined value. So now we're going to try an example problem, and it says, given the functions f of x is equal to 2x plus 3 and g of x is equal to x squared minus 1, find each of the following functions and state its domain. So let's first work on part A, f of x plus g of x. So if we were to put these values in, so this is f of x, and then we have to add g of x to this. So by doing that, we get 2x minus 3 plus x squared minus 1. And so our final answer for f plus g of x is equal to x squared plus 2x minus 4. For f minus g of x, it's the same thing, 2x minus 3, but instead there's a minus sign, and then there's x squared minus 1. And so you always have to remember to distribute this negative sign into both factors of this term. So we'll have 2x minus 3 minus x squared plus 1. So now our final answer for f minus g of x is equal to negative x squared plus 2x minus 2. For f times g of x, again we'll have the same thing, 2x minus 3 times x squared minus 1. So now we have to take it step by step and then factor. Let me do that with a different color. Factor in these and factor in these. So first we'll start with this. So we'll have 2x cubed minus 2x. Now we'll take a look at this. Minus 3x squared plus 3. Plus 3. So then our final answer for f times g of x is equal to 2x cubed minus 3x squared minus 2x plus 3. And finally, we have f divided by g of x. So we have 2x minus 3 over x squared minus 1. And we can't simplify this any further, so this is going to be our answer, and that is f divided by g of x. And so now let's find the domain for all of these as well. So important thing to know is that all polynomials have a domain of negative infinity to positive infinity. So this is the domain for this. This is also a polynomial, so its domain will be from negative infinity to infinity. This is also a polynomial, so its domain will be from negative infinity to infinity. And this is a bit different because it's dividing by an x value, so there's potentially an undefined value. So if we set x squared plus 1 equal to 0, we could see that if we subtracted 1 from both sides, it'll be x squared is equal to negative 1. Oh, sorry. This is x minus 1. So this is positive. And then x will be equal to plus or minus 1. So that means that the x value can't be 1 or negative 1. So its domain for this function is going to be equal to, go from negative infinity to negative 1, then from negative 1 to 1, and then from 1 to infinity. So that's the answer for that one. So this is it for part 2 of 1.1 review of functions, and in the next video we're going to be continuing reviewing functions in part 3.